So a car monitoring system provides information to the driver about the car's performance and alerts the driver to possible problems. Data about the car's performance is stored in three memory locations with addresses 601 to 603. The location 601 contains the distance traveled in the kilometers for the current trip as the binary integer. Location 602 contains the quantity of fuel used in liters for the current trip as a fixed point binary number with 5 places before the binary point and 3 places after the binary point. Such questions or a question more like this we solved yesterday or day before yesterday as well in the second variant. The four least significant bits of location 603, 1, 2, 3, 4 are flags used to identify problem with the car. For example, the fuel is low, a flag is set to 1, there is a problem, or 0 if not. The problems are bit 0, high engine temperature, bit 1, low oil pressure, bit 2, low battery, and bit 3, low fuel. Bit 4 to 7 are not used. So these 1, 2, 3, 4 are being used and these 4 are not being used. Okay. State the information that the current addresses of the contents of the address 601 to 603 will provide to the driver. Okay. So 601 is what? The distance in kilometers. So this will be 1, 2, 4, 8, 16. So this is 44 kilometers. 602 is a fixed point with 3 digits after it. So this one we 124, 5.125 liters. 603 is 5.125 liters. And third one is this part is not being used. These are being used. 0 is high engine temperature, 1 is low engine temperature, so low battery. Okay, so this is low battery. Now, a car has low oil pressure and low fuel. So low oil pressure, bit 1, and low fuel, bit 3. So bit 1 and bit 3. It has traveled 80 kilometers. So 80, 0, 1, 0, 1, 0, 0, 0, 0. So 64 plus 16. So this is 80. Now, it has used 7.25, 1, 2, 3. 0.25 means this, 7 means this. So this is 7.25 liters. All right. Now, this is our assembly language instructions. They all are those which are in the syllabus, so nothing new. Write assembly language instructions to set the contents of the address. Sir, if someone sends his digital signature to the other person, so how will the other person decrypt the digital signature since it is encrypted with the sender's private key? Ahmad, I told you that in asymmetric encryption, both the public and private keys can encrypt as well as decrypt. The restriction is that if you have encrypted using a public key, you cannot use the same public key to decrypt it. So you would have to use the private key. When the digest is being encrypted using Sam's private key, at the other end, Sam's public key will be used to decrypt it. Okay. All right. Please close your mic. Rizan. Mute. All right. Now, get it, Yusha? Good. Now, write assembly language instruction to set the contents of the address 601 and 602 to 0. Okay. LDM 0 store at 601, store and 602. And set all 4 least significant bit of content to 1. So LDM 0000111, or you can like 15, or maybe you can F and then store at 603 and then end it. All right. Oh, this should be not just F. This should be 0F because you have to use the whole byte. Okay. Part 2, a program continuously checks. Continuously checks means it will always be sending to the start. Check flags. So a program continuously checks the flags. If the flag is set, the program moves to the error handling routine. So remember, if it is checking this one, it is 1. If it is checking this one, this is 2. If it is checking this one, this is 4. If it is checking this bit, it is 8. These rest 4 bits are never checked. So no worries. Okay. All right. Load 603 and check if all are ones. As well. So if all are ones, store the loaded data into temporary. Okay, then end with 0, 1. First load the whole thing. End with all ones. Okay. And then store in the temporary the result. Then end it with 1. Compare with 1. Jump to high temperature. So this one is high temperature. Load again temporary. End with 2. Compare with 2 obviously. Jump to low oil pressure. Again load temporary back. End with 4. Compare with 4. Jump to low battery if it is equal. Load temporary. Compare with 8. Compare, end with 8. Compare with 8. If it is, then low. So this is now done. All right. So you would have to actually make your mind as per the requirement. Okay. So sometime if you don't get it by yourself, you are unable to write the program by yourself, then you can just read the code, rest of the code, and there you will find some sort of similarity, sometimes some sort of logical repetition of statements, and if you could make sense of it, you can solve such questions. Okay, so this is it for the paper. October, November 2020.